there is a blank copy there. If you ever do lose yours or whatever, or if you need another copy, I have a few extras. All right. So, as you can see, this unit has to do with trig functions. So if you don't have a calculator, go ahead and grab your line because we're going to use it for some things and not for others.
What's your number?
That's on the tender.
Oh. All right, now. So, all the stuff technically that we're doing today should be reviewed. But, you know, it's been a hot minute, so I'm going to keep it like it's not. But if you get lost along the way, say something. If you have a question, say something. I don't feel like I'm scary. All right. So, trig. Do you remember, or did somebody tell you or teach you maybe the, get my pen turned on, SOHCAHTOA? Yeah, no? Well, it helps you remember which side goes with what. Back when I taught geometry to sophomores, it was, we talked about a trig tribe, and it was Chief SOHCAHTOA, and I had students believing this. They were like, really? I was like, yeah. I came up with this. Now it's probably politically incorrect that I even talked about it. But anyways, the S, the big S, of course, stands for the sign. O stands for opposite. H stands for hypotenuse. C is cosine. A is adjacent. Again, H is hypotenuse. And T, the big T, is tangent. So if I'm looking at this triangle on the right, which side would be the hypotenuse?
AB.
AB. The hypotenuse never moves. The hypotenuse is always right across or directly across from the right angle. So this is the hypotenuse. Now, which side is the adjacent or the opposite depends on what angle you're looking at. So, for example, for this first one, where it says sine A. Sine A. That means you're looking at angle A. So for angle A, which side or which leg is opposite? It has to be named with two letters. Which side is opposite?
CB.
CB. Yeah, a side has to be named with two letters. You can't just say C. You can't just say B because those are angles. If you are trying to name a side of a triangle, it's BC or CB. So you said CB, so we'll say CB. And the hypotenuse, notice there's the definition over there. Opposite leg, CB. Hypotenuse was AB. Or, if you remember SOHCAHTOA, S is sine, O is opposite, H is hypotenuse. But spelling obviously is important. If you don't spell it right, then you're not going to know which goes with which. I'm not going to worry about cosecant or anything yet. Let's look at cosine right below it. Cosine of A is the adjacent leg. So which side is adjacent? AC. The side left out. That's how I always find it. So after I circle whatever angle it is that I'm talking about, the opposite is always directly across from the angle. The hypotenuse is, of course, across from the right angle. And the other side is the adjacent. So the adjacent side is AC, and hypotenuse did not change, it's still AB. And then for tangent of angle A, which side goes on top? CB. It's the opposite, OA, TOA, over the adjacent, which we said was AC. And of course, those letters can be flip-flopped, and it means the same thing. Everybody cool with that?
Mr. Lahan, he taught it as some on hippie, caught
Another hippie tripping on acid. Yep. Except for I did some old hippie caught another hippie. That also works, yes. Thank you for reminding me of that. It's been a minute. Oh, I don't know why I erased that. I meant to erase this. Okay, so now let's change angles. So if I keep going down this column, sine of B, so now I'm looking at this angle. That changes everything. So whatever angle you're talking about changes your opposite side and your adjacent side. Now the hypotenuse never changes. Let's see. Kendrick, what's the opposite side then? If I'm talking about angle B. AC, yes. So then the other side is the adjacent. So it changes. So you have to pay attention to what angle you're looking at. So what would sine of B be? Cameron?
Sine of B, so it would be opposite over hypotenuse, so it would be AC over AB.
Yes. What about cosine of B, Becca?
It would be adjacent over hypotenuse. So it would be CB over AB.
Yes, good. And tangent, Amaria?
Opposite over adjacent.
Yes.
Is AC over CB.
Very good. So we got that first column all filled out. Now, or the middle column, I should say. Okay, so notice on this first column, it tells us that the secant, which can be SEC, that's how we abbreviate it, but we call it secant. That symbol, what's that symbol?
Theta?
Theta, yeah, TH, theta. Okay, theta is defined to be the reciprocal of cosine, so you just flip-flop cosine. So whatever cosine is, secant is that flipped over. So, let me go ahead and do the rest of them too. Cosecant, which you would abbreviate CSC. Cosecant of theta is the reciprocal of sine, so I flip-flop sine. And then, makes sense, cotangent is COT, not to be pronounced cot, it's cotangent. Of theta is, you can't see it, but that says the reciprocal, you can see it on your paper, the reciprocal of tangent. So tangent flip-flopped. So, for example, sine A, notice directly across from it I have cosecant of A. So it's just AB over CB. I just take sine and I flip it over. Cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals, so I'm just going to flip-flop it. AB over AC. Tangent and cotangent. So AC over CB. That makes sense? We're going to do the same thing with B's. Cosecant of B, AB over AC. Cosine of B and secant of B are reciprocals. And cotangent and tangent. Okay, complementary angles. It says over here on the right. Complementary angles means that they add up to equal 90 degrees. So angle A and angle B are complementary angles. Because we know in a triangle, how many degrees are there? The whole triangle. 180. So if I have 90 right here, then the other two have to add up to equal 90. So when you have a right triangle, the other two angles, the two acute angles, have to be what's called complementary angles. Add up to equal 90. So what do we notice about sine and cosine for complementary angles? So sine of A and cosine of B. What do you notice?
They're the same thing.
They're the same thing. What about cosine of A? Cosine of A is the same as what?
Sine B.
Sine of B, yeah. So sine and cosine of complementary angles are equal to each other. And that's something that may come in handy as we go. So that is just reviewing SOHCAHTOA. And then did you guys do secant, cosecant, and cotangent before? No. Okay. Well, then that's introduced you to those, and it's just the reciprocal. Just where you flip it over. No biggie. Okay. So we're going to use these trig ratios to find some missing side lengths for us. All right. So we're going to look at this first one. If CB is 5, so we're going to call this 5. We're going to find the length of AC. So we're trying to find this side. I'm going to call it X. So this is the very first column. It tells us that CB is 5. And we're trying to find the length of AC. So that's why I put an X there. Does anybody already know what it is?
Yeah, it would be.
No?
I'll see.
It's okay. All right. So looking at these two, we have this angle. Because it says it's 45 degrees. And tell me what sides I have. I have the opposite side and the adjacent side. So think back to SOHCAHTOA. Which one uses opposite and adjacent? Tangent. So the tangent of the angle, which was 45 degrees, equals the opposite side, which is the one we don't know, over the adjacent side, which is the one we do know. So put that over 1, and let's cross multiply. So x times 1 is x. 5 times the tangent of 45 is 5 times the tangent of 45. Now your calculator is automatically going to be set up in radians. We need it to be in degrees. So if you will go to the mode button, which is right below the window button. So you have y equals window right below. See the mode button on yours? Looks, it's in the same place as mine on here. If you go to mode, yours doesn't look quite like this, but you're going to change it to degrees. So notice it says, mine says math print, normal, radian. Where it says radian, cursor over to where it says degree.